Sudden it falls apart. And now what happened here?
Don't want a complication.
What up, Sparky? It's your boy Evan here, and this video is the first preview of a new series I'm calling Understanding Incident Energy. Now, this is a huge topic to cover, so it's going to take a few videos, but I believe it's so important that we dive into it and fully understand this because it's widely unknown by most electricians. So stay tuned to these videos, share them with your friends, and let's just unpack this thing together. Now let's get started. Now, common engineering knowledge or wisdom will tell you that the farther you get away from the power source, the lower the available current or the flow of energy. And the closer you get to it, the more it goes up. Now, logic would tell you, not the rapper, but reasoning will tell you that incident energy should do the same thing, that as you get farther away, incident energy should reduce. Well, sometimes that's the case, but sometimes it stays the same and sometimes it increases. And that's one of the main topics that I want to cover here in this series. And I'm going to start with this simple concept, and I want to use this to illustrate a lot of things in the future, but this is what it is. It's that incident energy, I like to think of it as volume, and I like to think of available current as the flow, right? And here's why. Let's say that this cup represents a panel board and it's upstream or closer to the source where there's more flow. And the label for this panel board looks like this. And as you can see, there's 8 ounces of water in here or 8 calories of incident energy. And that's what that's going to look like. Now let's say that this is a panel board that's fed by this other one and it's downstream. But it also has a label that looks like this. And therefore it has the same 8 ounces of water or 8 calories of incident energy in it as well. Now, although they look the same and they have the same volume, remember this has more available current going to it or flow, and this has less. Now, I really want you to pay attention to this because this is why this matters. Now, why are they different? Although they're the same, it really comes down to time. Okay, now remember this one is downstream. So there's 8 calories and this is downstream where there's less flow. Now, here's the example. Let's say that I have my hands in this panel and then I got my suit on and all of a sudden it starts to fall apart. And because it's downstream, it's gonna take longer for the breaker to shut off because there's less current. And that's what that looks like. So now, let's say that we're working on this panel. Now remember, right now this thing's emptied on me, so I just got hit with all 8 calories or 8 ounces of water. Now, let's talk about the other panel. It's upstream, right? Same 8 ounces of water, but there's more flow there. Now, we'll take a look at this situation. I have my hands in this panel again, and I'm working on it. And then all of a sudden, it falls apart. And now what happened here? Well, it was a lot more flow, but the breaker is shut off a lot quicker. So it was over a shorter period of time. But I still ended up with the same 8 ounces of water or 8 ounces of incident energy that hit me. Now, you could imagine that if the second one or the one that was upstream continued to blow at that same rate, I would just be drenched with incident energy, right, or water. But luckily it shut off a lot quicker. So I ended up with the same volume, hitting me both times, but they were at different rates. Now, you probably have a lot of questions about this, and don't worry, we're gonna jump into this stuff as we unpack with these videos. But most importantly, I want you to just let this soak in. I want you to keep looking out for these videos, and most importantly, stay safe out there. Thanks for watching.
That was good.
We got it, right?
Yeah, I was a little confused because you didn't say